Okay, we're going to go over some of the test questions right here. So this first one, it says we need to solve the system of equations. So remember what that means is we need to get x equals some number and then y equals some number. We could do them in either order. Usually it's whatever is easier over here. Now as we see, none of these numbers really match up, so also the 4x is all the way over here. So elimination might be a little bit tough to do. Since we have just this one y by itself, I'm guessing we'll want to use substitution and get this y here by itself. So I'm going to do that. I'm going to rewrite down y minus 13 equals 4x. Get y by itself, I got to add 13 to both sides. Y equals 4x plus 13. Alright, so I can take this y right here and plug it into this y up here. So I'm going to rewrite this one as 3x plus 2 with the parentheses, 4x plus 13. Alright, well that's 3x. Got to distribute, so we're going to distribute that way. 2 times 4x is 8x. 2 times 13 is 26. This equals 4. Got to remember that. Alright, combine my like terms. 3x's and 8x's makes 11x's. Now I got to get these x's by themselves, so I'm going to subtract 26. 11x equals negative 22. Get x by itself. I'm multiplying, got to do the opposite, which is divide. So I get x is negative 2. Now that I got my x, I can plug that all the way in over here. So I'm going to come right here and say, alright, now I got to do 4 times negative 2 plus 13 equals y. So now I've got this right here is negative 8 plus 13 equals y, which makes me 5 equals y. So I've got my solution. Usually we want to write them as a coordinate pair, so I'm going to do that. Negative 2 comma 5. And the next part says explain what that solution means on a graph. So that means that these two lines are going to meet, they're going to intersect at negative 2 comma 5. Intersect at. And so that answers both parts of the question. Alright, on to number 2. We got to get the equation for this graph. So it looks like since we crossed the y-axis here, I'm going to use the y equals mx plus b form, because b is going to be this crossing point. So that's a negative 4. Now I need m. M is the slope. So remember, m is rise over run, or delta y over delta x, if you want to be very fancy about it. So I'm going to count the rise. 1, 2, 3, 4. So I want up 4, and over 1, 2, 3, 4, 5, 6. 4 over 6, so y equals 4 over 6x minus 4. And that just gives me the equation right away. That one's pretty nice. We don't have to do anything else there. As we keep going down, it says consider the following explicit sequence. Is it arithmetic or geometric? How can you tell? Well, I saw a lot of good answers on the test. Some people said, hey, this n is just being multiplied. It's not an exponent. Exponents are for geometric. Multiplying by the variable is for arithmetic. Or you could say that we keep adding 4 every time. So that's how we can tell it's arithmetic, because we're going up by 4 every time. To find out if 119 is a term in the sequence, we're going to plug that in for t of n and solve for n. So I can add 9 to both sides. So I get 128 equals 4n. Now I got to divide by 4. See, 12 divided by 4 is 3, and then 8 divided by 4 is 2. Yeah, that works out, because I got a whole number. So that works out perfectly. So I would say yes. On the back we had a couple cool problems. So we had to kind of continue the sequences that we see here. So here we go 8, 4, 2, 1. So we have to kind of think, alright, what's going on here? Well, minus 4, minus 2, that's not the same, so it's not arithmetic, it's got to be geometric. So I can divide by 2, or multiply by a half. Times a half, times a half, so I got to multiply by a half, so I get a half. A half times a half is a fourth. A fourth times a half is an eighth. So we just had to continue it on that way. That would be a geometric one. So that's a geometric sequence. 5, 5, 5, 5, 5, 5, 5. We looked at one kind of like this in class that was 8, 8, 8, 8, 8, 8, 8, 8. Hopefully we know it's just 5, 5, 5, 5, 5. This one's actually going to be both, because if we tried both of them, I'm adding 0, adding 0, adding 0, so that works. Or if I multiply, I'm doing times 1, times 1, times 1. So either one of those would work out. So that one ends up being both. Over here we had to read the y coordinates out. So we've got 1, 1, 2, 1, 2, 3, and 4, 9. I think it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. Sometimes it pays to double check. Alright, so we got 1, 3, and 9, so we have to kind of think that's what my sequence is right now. So if I'm adding, that's plus 2, plus 6, that's no good. If I multiply, that's times 3, times 3. Oh, that's working out. So I got to do times 3 again. So 9 times 3 is 27. 27 times 3 is 81. 81 times 3, I think it's 243, but I'm just going to double check. Yeah, okay, that looks good. And since we multiplied every time, that's another geometric sequence. Over here, we wanted to check out this one. So here I've got 1, 1 again. Okay. 2, 1, 2, 3, 4. 3, 4, 5, 6, 7, 8. So my y values again, we're going 1, 4, 8. Is that right? 1, 2, 3, 4, 5. Oh no, see. 1, 5, 8. Is that right? Something seems kind of off here. Let me just double count this one more time. Alright, so we got 1, 1, 1, 2, 3, 4, 5, 3, 6, 7, 8, 9. That's why I got 3, 9. Sometimes you gotta count them. Alright, so we've got our sequences 1, 5, 9. So over here we're going to multiply, we do times 5. That's definitely not times 5. Up here we got plus 4, plus 4. So we're adding 4 every time, so 9 plus 4, that's 13. 13 plus 4 is 17, plus another 4 is 21. And since we added every time, this is arithmetic. Alright, so now we need to do a recursive equation. So the first thing to do is to see, alright, is this going to be arithmetic or geometric? Well, again, if I add, I'm doing plus 2, plus 2, plus 2. So that means it's going to be arithmetic. So we have to remember that arithmetic formula, t of n plus 1 equals t of n. And then you just have to put the change down. And here the change is plus 2. The last part for recursive is we got to put down the seed. I'm going to say the first term, t of 1, is a 3. So I got my two parts. I got my equation, I got my seed. Second part, I've also got t of n plus 1, but now I got to check, that's going to be minus 18, minus 6, so it's not arithmetic. That's going to be divided by 3, so times 1/3, times 1/3. Okay, that works out. So it's t of n times 1/3. Now here's the key. With these ones, we want to say this is going to be, that's it. So we also need the seed. So I'm going to say t of 1, this time is 27. So that's kind of the two forms. The recursive ones are pretty nice. There's no exponents, there's nothing like that with those ones. Just says what are you doing every time, and then you also need your seed over here. That is 27. Alright, last one we have is Marty collects some colorful paper clips. He adds 5 every week to his collection. He had 7 when he decided to start. Alright, so we're going to add 5 every time, and he had 7. So an explicit equation, so we've got to do an explicit one, so that's one of the t of n ones. So we've got t of n, we've got 3 blanks, 1, 2, 3, because it's arithmetic, because he's adding 5. So that's t0, that's going to be 7, because that's what he starts with. because that's what it's going to be at week 0. Then our change is going to be plus 5, and then my variable is going to be n. Alright, now if you decide to make t0 a 2 here, that's okay too. Either one of those, because it isn't really clear if this is supposed to be week 1 or week 0. So either one of these two equations, that works out. So then to find out how many he'd have after 30 weeks, we want to plug a 30 in right here. 7 plus 5 times 30, so we get 150 plus 7, or 157.